diagrams are a particular tool developed by Captain Matthew Sankey, who used this diagram to show the energy efficiency in a steam engine in the 1898. But what are they? They're a visual representation of an input-output situation. It can help to represent energy, material, time, or any kind of flow. At the early stages, this tool only illustrates one flow. However, by adding colors to the rows, we can get more degrees of freedom using it in a wide range of applications. To draw a Sankey diagram, we need to know three things. 1. A system to be analyzed. 2. Identify system's inputs. And 3. All the outputs coming from the system. So now what? Let me guide you with a simple example to illustrate this tool. Imagine you're a university student who monthly relies on their parents' money. At the start of each month, your wallet will be filled with their money. This is our system's input. Finally, you have money. Wait a minute, you have some bills to pay. Living under a roof is expensive, so 50% of your money goes to rent. Oh well, you still have 50% left until you remember you need to pay another 15% on utilities. It's not too bad, you still have 35% left. Oh fudge, thinking about budgeting has made you hungry, so you spend the other 25% on groceries. Now let's be honest, as a university student, you will have 1 or 2 or even 5 crazy nights, so your last 10% will be spent on beer, clubbing, or entertainment. Without noticing, we have drawn a Sankey diagram. Easy, right? Yes, but we need to keep in mind two important things: proportionality of the inflows and outflows, and 2. Designating different colors to our flows to allow better identification. Now that you learn how to draw simple Sankey diagram, we can use this tool in a more useful, realistic engineering application. Picture yourself as part of a new team working in a turbofan engine manufacturing company. Your team is working in the development of a new turbofan engine to be used in small aircrafts of around 100 passengers, just like an Airbus A321A. The design of the turbine is focused on low maintenance, low weight, and efficient fuel consumption. However, the first test shows that fuel consumption is higher than expected, causing clients to cancel the order. Your job is to find the problem and fix it. Sankey diagram is ideal for solving the problem because it allows us to see the inflow and outflow in the systems by showing the percentages of its energy trajectory. Hence, undesired energy losses can be improved to increase efficiency of fuel consumption. To draw the diagram, we need to know how the turbofan works. First, air is absorbed by the fan. A portion of its air is used to generate thrust, and the rest is compressed and then mixed with fuel for ignition, which energy is used for the functioning of the components and to generate thrust. You then draw a Sankey diagram which looks like this. We have air and fuel as an energy input. Some part of the air is used to generate thrust, and the rest is compressed and mixed the fuel for ignition. From here, we obtain the output energy for thrust, sun energy, energy to be used in high pressure compressor, low pressure compressor, and the fan, and of course we have the unused energy. This Sankey diagram is an oversimplification, but it's enough for an imaginary example. After doing the Sankey diagram, you realize there is waste energy in the combustion chamber, implying that the fuel is not completely ignited. Your engineering knowledge, you know that this could be caused for the air not being at the correct temperature or pressure, so your suggestion is to improve the high pressure compressor. Thanks to the Sankey diagram, the problem was easier to detect, and so this problem was based on what occurred in 2005 to Pratt & Whitney when the turbofan PW6000 suffered low fuel efficiency. In this case, the low fuel consumption was caused due to air not being at an appropriate temperature, which was solved by adding one high pressure compressor stage, just like in the example we went through. You have learned today what Sankey diagrams are, how to draw them, and a practical example in aviation. Thanks for watching.